operational amplifiers, shortly many times I will call as opamps. Okay, opamps. Op-amp is a chip, is an integrated circuit, and it has a symbol like that. Okay, it has two inputs. One, this side is input side, this side is output side. It has two inputs, one output. Inputs are called minus inputs and plus inputs. Okay, and what does it do? It amplifies the signal, the voltage. Okay, if you apply some voltage here, like that, V in, it amplifies that voltage and gives to the output. It works like a dependent source, dependent voltage source. Look, this is plus side, this is minus side. You apply some input voltage. It works as a dependent source. A constant, a fixed value times the input voltage is introduced to the outputs. Okay, V out. And it works like an open circuit at the inputs. Okay, the input impedance or the input resistance, let me say input resistance, Rin, is equal to approximately very high. Okay, so you apply some voltage to the input, but there is no current. I plus is always 0, I minus is always 0. I plus is the current of this cable, I minus is the current of this cable. It's always 0 because there is a very high resistance at the input. And the output resistance is approximately 0. Okay, it behaves like there is no resistor at the output. And for example, if you give some small voltage V in, okay, it amplifies that voltage and gives to the output. If you give this voltage to the input, the same shape will be seen at the output, but it's amplified. Okay, the same signal, but it's amplified. Actually, it seems different, but I mean the same shape. Let me draw again. Okay. You give a little voltage, and at the output you will see the same signal. If this is a music, you will hear the same music, but it will be louder. Okay? And this constant value A is approximately, in practical amplifiers, it's approximately 1 million. Okay? If you go to a Radio Shack and buy an operational amplifier, for example, if you apply a voltage like that, 1 cos 50 pi t millivolts, microvolts, it will microvolts means 1 cosine 50 pi t 10 to the minus 6 volts. The output will be 1 million times higher. Okay, A times this much of voltage. For example, if A is 1 million, then V out will be 1 cosine 50 pi t volts, 1 million times higher. Okay, where does this high voltage comes from? At the input you have a very small voltage, but at the output you will see a very large voltage, 1 million times larger. This is your amplifier. You give small inputs, but you get a very large output. That large voltage comes from the sources. Okay, V plus and V minus. So actually there are two more connections to the operational amplifier. There is a positive voltage source, DC voltage source, and negative DC voltage source. Okay, the necessary voltage comes from those cables. Okay, you apply a small voltage, at the output you will see a large and amplified voltage. So please never forget this. There is no input current through the op-amp. Okay, so it's a very it's a perfect amplifier. It does not need any input power. Okay, it gets the power from the sources, DC sources. You apply some voltage, but you don't need to give some current, and your signal will be amplified. Yes, there is a very high impedance at the input, high resistance, so there is no input current. So let me show this graphically. For example, if you apply a signal like the green signal, okay, assume that the green is input, okay, and the red is the output. Okay, in this figure, V out is approximately 5 times higher. Okay, and you apply a small voltage. Okay, for example, you apply 1 volt minus 1 volt, but at the output you see a voltage 5 and minus 5. Okay, so this high voltage comes from the voltage sources connected to the op-amp. Okay, they come from here, this voltage source and this voltage source. So for example, if you change the amplification, if you make this 20, so now what will be these voltages? This will be, yes, 20 and minus 20. Okay, is there any problem if your voltage sources are higher than 20 volts? There is no problem. But assume your sources are 15 volts. What happens now? Okay, I have connected 15 and minus 15 volts. Now, is it possible? Can I see 20 volts at the output? No, because higher voltages comes from the sources. So what will be the situation? The situation will be something like that. 15 minus 15. The output voltage will be okay if it's between minus 15 and plus 15. But over that voltage, it will be saturated. What does it mean? It means this. This will be the output voltage. It cannot exceed 15 volts. No. If it is higher than, if the output voltage should be higher than 15 volts, the output will be 15. Okay? So it will never exceed plus 15 and minus 15. Okay? The output is like the expected shape if the expected value is lower than 15. Okay? Cannot exceed 15 volts. That's called the saturation. It means I cannot go more. Okay? And look at the values. Now the gain is 20. But real opamps have a gain of approximately 1 million. Okay? So if you give 1 volt input, the output should be 1 million volts. It's impossible in practical applications. So what happens? For example, you have a real op-amp like that, and you apply this voltage. Okay? Consider you have the same, okay, same input. You apply this input to a real op-amp. What happens to the output? The output should be between positive 1 million, negative 1 million, but it's impossible. It cannot exceed 15 volts. The output will reach 15 volts when V out is equal to V in times 1 million. So this can be maximum 15 V in times 1 million. So when V in, the voltage of V in is equal to 1 million, okay, which is what? 15 microvolts. Okay, when V in is higher than 15 microvolts, the output will saturate. It will be fixed at the 15 volts. Okay, so the output will be like that. Let me draw the output. Output will be okay. It will immediately reach to 15 volts, and it will be 15 until when? Until which point? Until the voltage switch to a negative value. Okay. So the output will be like that. Okay, can you understand? If the voltage is positive, I mean positive, it's higher than 15 microvolts, and in daily life, in practical applications, 15 microvolts is very, very low. Okay, you cannot find that much of small voltage. Okay, you will deal some voltages, all of those voltages will be higher than 15 microvolts. Okay, you will have some voltage, it will be always higher than 15 volts in practical applications, 15 microvolts, and it will be always either higher than 15 microvolts or lower than minus 15 microvolts. So you will always see positive 15, plus 15, or minus 15, negative 15 volts at the outputs. This is V out. This is V in. So how can you see 0 volt at the outputs? Okay, this is the op-amp. If you connect a cable here, then V in is 0. Okay, so V out will be 0 times 1 million, which is 0 volts. Okay, otherwise, if you connect any components, any circuit, you will never see voltages except plus voltage source and minus voltage source.